At this point, we have all of our articles, and we have labeled them as either news articles or other articles. And we also have our article to classify. And we've parsed the headline of that article to classify into individual tokens, each token being what we called an important word. And you can see these important words down here for Article 53. It was one of the examples that we're going to look at to demonstrate this code, and it has been broken into art, questioning, jogger, defense, lawyers, fear, colleagues, and cross-examinations, noting that we have taken out the alphanumeric characters, and that can be a good thing, or it could also offer some challenges. There's always a way, usually, to improve code. We may or may not want cross-examinations here. Maybe we want the dash. Not going to make a big deal one way or the other in terms of seeing how this classifier works. But what we want to do, again, the general strategy is to take this first word, to take each word, but we start with the first word and look at what percent of the news articles have that word and what percent of the other articles have that word. And then record that and go to questioning and do the same thing, and go to jogger and do the same thing, and then sum up all those percentages for the news articles and sum up all those percentages for the other articles. And one way to make the decision is whichever one has the biggest sum, we'll classify it as that particular category, news or other. So in order to start that, we of course need these percentages, and a percentage is a part divided by the whole. So to get the whole, we're going to have to find out how many news articles and other articles there are altogether. So I'm going to simply filter all of the articles for the news, and I'll put those in what's called news articles. So it takes all the news articles and puts them into this object called news articles, and I'm going to do the same thing for the others. And I do that, and then I will go and simply find out how many of those news articles there are. I'll look at the number of rows in that data frame. So dimension news articles gives me the number. If I look at the first number of that, it'll give me the rows, the number of rows. The second one would give me the number of columns. So I'm going to do that for the news articles. I'm going to look at the first dimension, which is the number of rows of the others, and that is equivalent to the number of news articles that are out there and the number of other articles that are out there. So I'll go ahead and print those. So I have 317 news articles and 120 other articles. So we mentioned before that we're going to get these percentages for each word, and each word will have a percentage in the news and a percentage in the other, and we're going to store those in these arrays called percent holder news and percent holder other, and we're going to populate that here in a second, but this is where we're defining it outside the for loop, so it exists globally, not just in the for loop. So this for loop is very intuitive, because what we want to do is do something for each word. We want to go to each word and, again, find that percentage for news and other. And that's what this for loop is going to do. So the for loop simply says for I in 1, the first word, art, to the length of important words, which would be the index of the last word. I think it's 7 or 8 here for cross-examinations. For each important word in the headline, I want to do the following. And what would that be? Well, it's simply going to say, well, for each word, again, I want to go through all of the news articles and see how many times I found that word. And that's what string count is going to do, or string count is going to help us. I'm just going to dissect this piece by piece. Now, this is in a for loop, so it's going to have I equals 1. Notice that there's an I in here, so I'm going to very carefully change that I to a 1 to mimic what this for loop is doing without actually running the for loop. So it's going to say string count. Remember, we'll say how many times it sees that word in these news articles. So news article, response, docs, headline, important word number 1, which is art. I'll hit enter, and that's 300, that's 311, 12, 13, 14, 15, 16, 17. And note that that we knew it was another article, but it is actually coming up in some of these news articles. So, and I can get a frequency from that. So what I want to do is, of course, sum all those up. It's a bunch of zeros and a few ones. I want to just count them by hand. So I'm going to sum all of those up, again, being careful here to replace that I with a 1, and it will sum up all of those words. And I didn't get that last parentheses on there, so I'll just add it right there. And there were 4. There was 1, 2, 3, 4. So it added them all up. Great. I'm going to do the same thing, so that's going to become num news. So that's the number of times I see the ith word in the news articles. In this case, I is 1, so I'm going to go ahead and do that. Actually, let me go ahead and just for purposes, make this a 1, because I could be something else, and let's confirm that num news is, again, 4. Yep. So I'm going to do that same thing here for other. And again, I'm changing this I to a 1 just to mimic what the for loop's doing. We're going to let that for loop run here in a second. So I do that, and number of other articles that have it is only 1. It's only the one that we found. So that could be interesting. I'm interested to see how it classifies this now. It looks like art is a fairly prominent word, and it definitely comes up in both news and other articles. So the next thing we're going to do is we have everything we need for percentage now. We know how many times we found art in all of the articles, in all the news articles, and we know how many news articles there are because I got it up here where I counted the rows. So all I need to do is divide the number of news articles by the number of news articles that contain that word art divided by the total number, and I'll have the percent. And then I'm going to put it in, since I is 1, the first element, the first position of that, the percent holder news holder or array. And I'll do the same thing. In the first one, I'll say num other, that's the number, that's that 1 divided by, so that'll be 1, whoops. So we knew here, let's get this, num other articles is 120. So this percent will be 1 divided by 120. And this percent will be 4 divided by 317. And that's what we'll store in the percent holder. So let's do that because we'll see that here in a second. So 4 divided by 317, oops, 4 divided by 317 and 1 divided by 120. So if art was the only word in there, I would classify this as a news article. Even though it's another article, this classifier would classify it as a news article because the news has a higher percentage than the other. But there's more words in here, so let's let all of the words work together. So at the end of the day there, notice, well, inside of here, this isn't really, this is inside our for loop. This was just for debugging purposes, but it will print out the percent holder news and the percent holder other each time. But then at the end of that for loop, we'll have the percent other news. And when I print this out, it should have 8 different percents corresponding to the 8 important words in the headline for the news articles and the 8 percents for the 8 important words corresponding to the other articles. And let's go ahead and run that, and then I'll show us what we're going to do down here. This is pretty slick. So let's go ahead and run this for loop. And now we're going to let I equal 1. Let me make sure I've kind of run all of this. So we'll run that. So it's done this. Now it's going to start with I equals 1, and it's going to do what we just did, but do it for each one and store those percents. So I'll go ahead and do that. And now it just ran through and just did it for I equals 1 to 8. So now these should have in here, if I look at percent holder news, those are the percent holders, 1, 2, 3, 4, 5, 6, 7, 8. And notice when we calculated it by hand up here, 4 divided by 317 is 0.0126. And sure enough, that's the first one here. And that's the one for art. This one's the one for questioning. This one's the one for the third word. So let's see what those are for other, just like that. And we've got those for other. And what I want to do at the end of the day is sum them up. Whichever one has the biggest sum, kind of looks like, to me, news is going to win here, but let's let it do the math. So I'm going to say classified as. So we know the true type, but now what did our classifier classify it as? Well, it's very simple. If else statement again. If else, the sum of the percent holder news is greater than the percent holder other, then classify it as a news. And if it's not, then let's classify it as an other. And so if we add all these guys up, it will be, so let's look at classified as, and it did. It classified it as news. And if you wanted to look at those individual sums to see the magnitude of that, it was a 0.422 to a 0.1. So though the sum of all these numbers, art had a much higher frequency in the news articles than it did in the other articles. Not art, but all the words together. So great. So then we can kind of, I'll say get fancy. This is just kind of cool. You can build a sentence. So this is just using string C. I can say the, and then I'll put in true type. Remember, true type is something that we said earlier. What is the news or other value of this particular article 53? So the true type is going to stick that in there. And then it'll always say article was classified as, and then I'll put in the classified as, that'll be news or other, with a score of, so then we get an idea of our uncertainty. Is it close or was it lopsided? So round the sum percentage news, and an other score of round the sum percentage holder, just like that. So, and then we'll stick a period. We're going to round that to 4 decimal places, and we'll stick a period at the end of it. Notice that I've put in all the spaces on my own. So that's kind of nice. At the end of the day, when we run this a bunch of times, we can just read it. The other article was classified as news, so we know we made a mistake, or the classifier did, with a news score of 0.422 and an other score of 0.1. So I can get an idea that, yeah, it wasn't even close. Isn't that cool? So actually, let's run this a couple of times for some of those other articles. So that was for Article 53. What if I did now Article 141? And you can play around with this and highly encourage you. Hopefully you're following along as we go. That's really the best way to learn this, and maybe the most fun as well. So there's important words. I'm going to do all that parsing, and we're going to run it. I'll do the visualization next. That's what we're going to talk about next. But for now, I'm just going to go down to my result, and we'll run that. It's doing that for that article. So that article 141, the news article 144 turned out to be a news article, was classified as news with a news score of 0.0158 and an other score of 0.0083. So that one's a little bit closer, but it correctly classified it. Isn't that awesome? So let's do one more. We know the last one here is 309 that we wanted to look at. You can play around with any of them. 309. We know it's an other article, so how well is it doing? And we run that guy. And the other article was classified as other. Awesome, with a news score of 0.0126 and an other score of 0.025. So again, pretty close, but it classified that one correctly. And that's what a classifier does. We'd like for it to be 100%, but a lot of times that's not realistic, and we're just trying to get something that's better than what we would do by randomly guessing. And what we'll do in later units is find out how to evaluate these type of classifiers as well as develop better classifiers. Again, we're really just showing off what a lot of the methods and functions that and ideas that we've learned up until this point. So that is really the big idea. But as with any good data science method or data science application, visualization is going to be a key when you're trying to present it. And I think we've got some pretty cool real visualizations of this. So I'll see you in the next video, but great job with this one. Play around with it, and I'll see you in the next one.